Maybe you've heard terms like big data or data mining or machine learning. Perhaps you've encountered words like artificial intelligence and complex network. This course is about all of these and then some. Welcome to Analytics and Predictive Modeling. So what do we mean by analytics, and what does it mean for a model to be predictive? Let's go to the source. Wikipedia tells us that analytics is the discovery and communication of meaningful patterns in data. That tells us that predictive modeling is the process by which a model is created or chosen to try to best predict the probability of an outcome. In other words, the purpose of analytics is to discover trends, patterns, and similar sorts of phenomena inside of large data sets. And predictive models are the algorithms with which we find those patterns and trends. That is, if you've heard the term predictive analytics, that's nothing more than analytics via a predictive model. You might ask, aren't all models predictive? And we'll answer that question by looking at descriptive models versus predictive models. Descriptive models are the types of models you might be most familiar with, those from physics and the other sciences. They tend to begin with assumptions, universal gravitation or a constant per capita growth rate, and then models are derived from these assumptions. So from universal gravitation we get orbits being elliptical. From constant per capita growth rate we find out that growth is exponential. We obtain data based on these models, estimate parameters that are in the models, and then we get predictions from the model itself. In other words, predictions for descriptive models tend to be features of the mathematical models and their interpretations in the real world. Predictive models, on the other hand, begin with complex data sets that may be very large. For example, the human genome or social networks. We tend to get these complex data sets before we design models or experiments, and so therefore we have the data sets a priori and ask questions. What genes are related to a given cancer, or is the network small world? We apply algorithms that predict answers, and then we evaluate the results. So what is the role of big data in all of this? Well, first off, let's consider what the role of data is in general. In a descriptive model, we typically have an experiment based on the model, and the data that's produced is used to estimate parameters, make inferences, and test hypotheses. The problem with big data sets is that they're so big and so complex that they don't tend to allow the type of traditional parameter estimation and hypothesis testing. It could be that they're too complex to allow such things, or it could be that they're so large that obtaining such estimates and measures would take years or decades. So that means the goal for analytics, which is related to the role of big data, is that we want to be able to extract useful information from large, complex data sets in a timely fashion. So what is the predictive modeling approach? Well, we begin with a data set and a question, or questions. And we have a large set of data. We explore the data because, after all, the answer may be obvious from just looking at the data. There's usually some kind of a pre-processing step. We may want to transform the data, especially if some of the factors are relatively large in magnitude. We might want to normalize the data. We often transform so each factor has a mean of 0 and a standard deviation of 1. And then, once we've pre-processed and are ready to actually get information, we use the data mining allegory, which is that we're mining big data in the sense that we want to get desirable information from the rest of the data. And once we've done so, of course, we'll want to assess the results. Now, the canonical example of this are classifiers. So you can think of a classifier in the data mining allegory like panning for gold. So data is either in class 1 or class 0. We can consider multiple classes, and will later on, but for the most part that tends to be a natural generalization of the class 1 or class 0 approach. And we are panning for gold, and in this sense the class 1 would be the gold, the thing that we desire among all the other stuff, most of which we just keep continuously throwing out. So most important perhaps is what we're actually mining into. And just like the data mining allegory, we tend to have lots and lots of things in our data sets that we're not interested in, but a few extremely valuable nuggets of information that we do want to obtain. And typically those are very hard to find, just like the panning for gold analogy. Now, this might seem like it's sort of ancillary, but it turns out that big data is the norm in science and technology today. Everything from the Large Hadron Collider to the everyday smartphone. All of these produce what we call big data. So our first task, perhaps you've already realized this, is we need to answer a question. What is big data? And that's what we look at next.